Hello everyone. Today we are going to discuss this question called sort zeros, ones, and twos. So what you have is an array which only contains 0, 1 and 2's randomly. It could be at any order. It could be something like this, let's say, and your task is to put the zeros together, then put the ones together, and then put the twos together, right? And by together, like in order: first zeros, then ones, and then twos, right? So we need to write an efficient code to solve this particular problem. So what could be the most naive thought process is, why not just sort the array? So if you have an array a, so you just write the function sort of a comma a plus n, and uh, you will definitely have your answer. But that is computationally more expensive, so that will take more time. uh, this particular sort function, as we all know, takes n log n time, so uh, not the most optimal way, right? Okay, so we have a very interesting way to solve this problem, which is using three pointers. So let's discuss that how do we place those pointers so as to optimally solve this kind of a problem. So let's say you have elements like this, a1, a2 till an. So the way you will position the pointers is something like this, that you'll have a pointer called L, which is the low pointer. You'll initialize it at index 0. The high pointer will be at definitely index n minus 1, and you will initialize another pointer which will be at m equal to 0. This is the mid pointer, right? So that's your low, that's your high, and that's your mid, right? So see what the idea is. The idea is you go through the whole array, right? And if you find an element that is 0, so you throw it on the left. So basically what you're doing is, let's say I find some element here, okay, and I find that it is 0. So what I do is, I have a left boundary, right, before which everything is 0. So what I tell is, let me swap this thing with this thing, right? So the left boundary is at such a place that before that everything else is 0, right? So we have all zeros before, right, and we have L here, right, and we have some, your mid is somewhere here, and let's say you found a 0, right, and this could be any element. This could be, let's say, some x, which could be either 0, 1 or 2. So what you do is, as you get your mid is equal to 0, so you just swap your ARR of mid comma ARR of L. So that is when you get a 0, right? Okay, now when you get a 2, then what you're going to do, 2 has to be placed. Okay, so you also position a high pointer, and the high pointer is placed in such a way that whenever you get a 2, right, you throw your 2 to the rightmost extreme, and what you do is that you will shift your high pointer to one space left, so you will do h minus minus. And similarly for L, you will do L plus plus. And definitely, m plus plus is something that's happening all the time, that's for sure, that will happen, right? Okay, so okay, now what if you get a 1? So just think it this way, that if you are throwing all the zeros to the left hand side, all the 2's to the right hand side, then what happens? The ones are not being thrown to any side, so the ones will always be there in the middle. So the point is, if I get a 1, I can just do mid plus plus, and that works, right? I hope that makes sense. So the code, if you write, will just be like this, that you initialize L equal to 0, your mid equal to 0, and your high equal to n minus 1, and you will simply write the condition that you, because see, your mid is the thing that you're traversing, and your mid will definitely not exceed high, because high is the extreme at this point. So till this condition happens, and it's very simple. So if your ARR of mid is equal to 0, so what you do is you swap your left pointer with the mid pointer, and what you do is you do L plus plus and M plus plus, right? Similarly, as I told you, if for getting a 2, you will simply do the other swap, which is nothing but swap a of m comma a of r, and you will definitely decrement your r. And if you have a 1, then if you have a 1, in that case you just go m plus plus. So that is the whole idea. And after this, after performing this till the terminal condition, which is this mid less than equal to high, the array that you will have will already have zeros, ones and twos all in a sorted order, right? uh, we can try with with an example to see if we are correct or not. So let me just pick this example 2 0 2 1 1 0. So this is my left, this is my mid, and this is my high. So at first the condition is nothing but while mid is less than equal to high, which is satisfied. So I get that my mid is equal to 2. So I'll swap this with this, right? That's how the swapping occurs. So let me just convert the array to 0 0 2 1 1 and then 2, right? Okay. So now tell me one thing, that you have your 2 here, so you are definitely doing h minus minus, right? Because uh, what is your high? Your high is basically that location where afterwards you have all 2's, right? So afterwards you are having all 2's. Okay, fine. So I hope that makes sense. After this, as you see that your m is equal to 0, so you will just swap your m and l, which will not result in something, because here your m and l both are 0, so no swapping actually happens. So then your l and m both are basically incremented. And okay, so there's one very interesting thing, that while writing the code, we saw this thing, that uh, we are doing both m plus plus and n plus plus in this case, whereas we are doing only uh, your r minus minus in the case of getting a 2. The reason behind that is this particular element, right? When you're coming from the left, so everything before that has already been processed, so whatever you're shifting must be a 1, right? Because see, the point is, if I'm at some mid, right, and I don't know what that mid is, right, and if I'm getting it to the left, if I'm swapping it to the left, so whatever comes from the left is definitely a 0 or a 1, right? It can't be anything other than that. If your low is equal to mid, it will be a 0. If your low is lesser than mid, it will be a 1, right? But it can't be anything other than that, right? But when you're swapping, let's say this element with this element, so this has not yet been processed, so this could be a 1, this could be a 2, or this could be a 0. So therefore you have to look at the element that comes from here, right? You can't do mid plus plus in that case, but you can do mid plus plus here. So that was the idea of the problem. Hope you understood. Thank you.